Hello guys, welcome to the today's LeetCode problem. Today's LeetCode problem is a medium level and called as a minimum index of a valid split. What is the problem says that? The problem says that we have the element x of integer array ARR of length m is a dominant if more than half the elements of ARR have the value x. It means that the dominant element must be occurring more than half of the elements in array. If my array has a length m, then the frequency of dominant element must be greater than m by 2. This is something that the line is saying that, and this is very important. Okay, so you are given a zero index integer array nums of length n with one dominant element. So this is also important that there will be always only one dominant element, means only one element would be there who has a frequency greater than half of the length of the array. You can split num at any index I into two arrays. Okay, that is num 0 to I and num I plus 1 to n minus 1. But the split is only valid if I is first of all in between the length of the array, and num of 0 to I and num of I plus 1 have same dominant element. It means the split should have the same dominant element in both the splits. So here the num of I to j denotes the subarray of num starting at index I and j inclusive. Okay, that is something that we have to make sure. Particularly j should be less than I. Then num of I to j denote the empty subarray, and we have to return the minimum index of valid split. If there is no split exists, then return the minus 1. So I hope you got it. So two observations are there. First, that dominant element has frequency greater than n by 2. This is one of the case. The second is only one dominant element is there. This is also something we have to take in mind. So let's see about this case. So what we can do, simplest way would be that if you see first observation, only one dominant element, and dominant element has a frequency greater than n by 2. So best way would be just count the frequency. 1 has a frequency 1 and 2 has a frequency 3. And what is given? Frequency should be greater than n by 2. What is the n here? N is a 4. Correct. So let's find. So frequency for 1 is a 1. So what is a 1 greater than 4 by 2? No, because 4 by 2 is a 2. 3 is greater than 4 by 2. Yeah, it is. So it means that I am 100% sure that the dominant element is 2 now. But second step is a find valid split, means valid index where we can split it for the 2. Correct. So what we can do, we can start from here. Correct. Now we know that we have the frequency 3. Correct. I will try to split the array after the 2 whenever I encounter the 2 over here. So in this case I have 2 here. Can I split it here? Let's see. What is the length of this array? Sub array, that is a 2. What is the frequency of 2? 1. Correct. So what we have to do, we have to make sure that the frequency of the 2 in this sub array should be greater than n by 2. Correct. So frequency of 2 in this sub array is 1 only. Is it greater than, what is the length? 2 by 2, that is 1. So is 1 greater than 1? No, it is not, because 1 is equal to 1 only. Correct. So no, it is not a valid split. So what I will do, I will go forward now. Now I will try to split here after this. Correct. Now see, what is the length of this sub array? 3. So 3 by 2 I want, the frequency should be greater than this. Correct. What is the frequency now? Here 2 only. Correct. So is my 2 greater than 3 by 2? Yeah, it is. So correct. But I have to check this side as well. Correct. So I will check. What is the length of this sub array? 1. So 1 by 2. And what is the frequency of 2 here? 1. So is 1 by 2 smaller than 1? Yeah, it is. So I can say that this is my valid index to split it. That is a 0, 1, 2, 3. So 2 is my index where I can split it. That's why the output for this test case is also this one only. Okay, I hope you got it. Let's try to understand this, what I was saying about the split part. Correct. So split part that we discuss now, just split part. Okay, what is that? First of all, we should know. Okay, take the total frequency. that you will have, right? Because in first go, what you will do, whenever you are trying to find the dominant element, you should know the frequency initially, right, for all element, correct? Once you know that part, now what you do, at each step, at each index, what you have to do, just do what, prefix frequency till that index, correct, till that index should be greater than I by 2, correct? I by 2 means if I am here 0 1 2 3, if I want to split here, this is my I, right? So frequency till here, this is my prefix frequency. This frequency should be greater than this I by 2, that is a 3 by 2. So it is a zero based indexing, so it should be I plus 1 by 2, correct? And second, at the same index, check remaining frequency, it should be also greater than what, n minus I minus 1 by 2. What is the n minus I minus 1 by 2 is basically this thing. What is the n here? 4, because we have 4 elements. So 4 minus 2 minus 1 is nothing but 1 only, because only one element is remaining, by 2, correct? And this remaining frequency will nothing but total frequency minus prefix frequency, correct? So this we will check, and at any index, if these both conditions are satisfying, it means we will just return that I, correct? Just return that I, because that is my valid index, correct? So this is how we can solve this problem. So what is our first goal? First goal is that find a dominant element first. To find a dominant element, we have one case, right? What is the case? That the dominant element frequency should be greater than n by 2. So what is n here? So 1 2 3 4 5 6 7 8 9 10, correct? So n is equal to 10, correct? And our frequency should be greater than now 5. This is our goal, because 10 by 2 is nothing but 5, correct? So we will try to find the frequency of each element. So if you see the frequency of 2 in this case, I will just write this array over here. So it is a 2 1 comma 3 comma 1 comma 1 comma 1 7 1 2 1, correct? This is my array. I will try to put the indexing as well. 0 1 2 3 4 5 6 7 8 9. Now what is our first step? First step is a find dominant element, and by the observation only, they have said that there is only one dominant element in an array, so we don't have to worry. So at any time, okay, the frequency of any element, okay, element is greater than n by 2, then it is a dominant element. You can write this as well, or you can write this as well. 2 into frequency should be greater than n. This is simple mathematics, right? If this 2 is here, the divisor, it can go for the multiplier in this side if we shift it from left to right, correct? So both are same cases only. So what I will do, I will try to find the frequency of each element. So frequency of 2 is 1 and 2, correct? Frequency of 1 is a 1 2 3 4 5 6. Frequency of 3 is a 1 only. Frequency of 7 is a 1 only. So 6 plus 2, that is a 8 plus 1 plus 9. 9 plus 1 10. So this is our frequency array, looks like this. What we will do, we will iterate over each of them one by one, and we will check if the frequency 2 into frequency is greater than n or not. So 2 into frequency is greater than 10 or not. So I will come here for 2. So 2 into frequency, that is a 2 again. Is it greater than 10? No, it is not, because 4 is not greater than 10. For the 1, 6, 2 into 6 is greater than 10. Yeah, 12 is greater than 10. It means I found the dominant element, and I will break it, because I know there is only one element. So other remaining element would not be the dominant, that is 100% sure. So I will break. I will not check for other further elements. Even if I checked it, so 1 into 2 or 2 into 1 is not greater than 10. Same for 2 into 1 is not greater than 10, right? So there is no sense of checking the further element, as the problem says that there is only one dominant element. Correct. Now we know that we have the dominant element with us. Correct. So the dominant element right now is a 1. Correct. And total frequency is 6. Correct. Now what I have to do, I have to maintain two variables, that is you can say current frequency, which is nothing but a prefix frequency, and remaining frequency. And remaining frequency will nothing but a total frequency only, that is a 6. This will be initially will be 0, right? Because we are starting at a 0th index. I will just take this one. Okay, I have put it here now. Now let's try to find it again. So now right now I am here. Okay, I have missed something, that is 2 was here, correct, with a 0th index. Right now I am here, correct. I is my here, makes sense. Now is my, I will check, is my current num of I, okay, my condition, if my num of I is equal to dominant, first of all, that is my check first. If yes, what we will do, we will just say current frequency increment by 1 and remaining should be decrement by 1. This is my goal, remaining frequency decrement by 1. So this should be the decrement operation, correct. This is what I am doing over here. So 2 is not equal to the dominant element, because dominant element for now is 1 only. So no, it is not. So I will just move ahead. I am here now. Is it? Yeah, it is. So what I will do, I will just say, okay, now my current frequency is 1 and remaining is a 5. I am just following this case, correct. And after that, at every step, what I will do, I will just check if this condition, index and this condition. So how can I write it? I will just say if at any step, if 2 into my current frequency, this is what we are checking, right? 2, if it is greater than I plus 1, as it is 0th indexing, and 2 into remaining frequency, if it is greater than n minus I minus 1. So I will just say return that index. That's it. This is what we have to do. Else at last what we can do, return minus 1 if there is no valid split. So right now my current frequency is 1 only. So 2 into 1, is it greater than I plus 1? Right now I am at a 1 index, so it is I plus 1, that is 1 plus 1, that is a 2. So you can see 2 is not greater than 2. So no. So there is no point of checking this remaining condition. So I will move ahead. I am now here. Since it is not a dominant element, I will move. Then I will again check my 2 into current frequency is 1. Is it greater than 2 plus 1, that is a 3? No, it is not. So I will move here now. Now it is related to the dominant element. 1 is the dominant element. So again I will increment my current frequency by 1 and decrement the remaining frequency by 1, that is a 4. Now I will again check my current 2 into current frequency. So 2 into my current frequency now is 2. Is it greater than I plus 1? My I is at 3rd index, so I plus 1, that is a 4. So again 4 is not greater than 4, so I can't, so this condition becomes false. Again I will come here now. Now my current frequency will be incremented by 1, is as it is a dominant element, so it will become 3. This will become 3. Makes sense. Now I will again check. So 2 into what is my current frequency now? That is a 3. Is it greater than I plus 1? I is my now at 4th index, so 5th, right? So yeah, 6 is something that is greater than 5 now. Now let's check for this other condition. 2 into remaining frequency. What is my remaining frequency? 3. Is it greater than n? N is nothing but 10 minus I. My I is now 4 minus 1, that is 10 minus 5, that is again 5. Yeah, so 6 is greater than 5 and 6 is greater than 5. That is something that is valid. So I will just say return I. What is my I? I is 4. So I will just say return 4. This is the valid split. And if you see, if I split my array over here, you can see 1, 2, 3. So 3 ones are there, correct? and in this case also 3 ones are there, and the length is 5. So out of the 5 elements, 3 elements are only 1. That's why 1 is the dominant, and the test output for this test case is also nothing but the 4 only. Correct? So this is how you can solve this problem. And one case should be there, y I plus 1 and y n minus I minus 1. So if you see, this is a 0-base indexing. So if we are here, we know that there are 5 elements. That's why we have to take I plus 1 over here, and same for here. If you see, if we are here, so how many elements are remaining? 5. So if you see, total elements are 10 minus this current index, correct, that is a 4. So it says that there are 6 elements still remaining, but actually due to the 0th bit indexing, here were the 5 elements. So that's why we have to take extra minus 1. So it will ultimately give us the minus 1, 5 elements. That is the valid elements remaining. So I hope you got this problem. The logic was simple. First was the find dominant element. Second was just check for every index, is it a valid split or not, using this if condition only. So code for this problem is simpler over here. I have just written over here. What I am doing here, I have just counted the frequency of my array. So this counter in Python is basically written the frequency of each element that we were doing initially over here. This one, this part, correct. Then I am taking the length of the array. I have just initialized my dominant element with minus 1. I am looping over all the elements in my hash map or in my frequency array, this one, correct. Then what I am doing, I am just checking if 2 into frequency is greater than n at any time for any element. Same thing, right? Same thing here. 2 into frequency is greater than n, this part. Okay. I am just checking. If it is the case, then I have found the dominant element, and I will break it because I know there is only one valid dominant element present in an array. That is something given us as an input, and I will break it because I want to do the early stopping. Then again, 2 variables, current frequency, total frequency. That is the remaining frequency we were referring. So total frequency will be the frequency of dominant element. Then I am looping over the array from 0 to n, and I am just checking if my current element num of I is equal to dominant, then increment the current frequency and decrement the total frequency. That is the remaining frequency. And same check over here as well. 2 into current frequency, that is this one. If 2 into current frequency is greater than I plus 1, and 2 into total frequency is greater than n minus I minus 1. If it is a case, then return the I, or else return the minus 1 at last. Correct? So total time complexity would be the big O of n only, because counting the frequency take big O of n. This loop also take big O of n. This loop also take the big O of n. And the space would be the big O of n only, because we are using the frequency array. So I hope you got this problem. See you in the next video. Thank you.